Alright, this is the second part of your point 3 notes. This is solving exponential equations. Uh, Usually if we solve an exponential equation, we need logs in there, some way, shape, or form. So we're going to solve these equations, and in particular when we get to the size where we bring in logs, we're going to use base e or base 10, just so we can approximate it with our calculator. Remember, base e is the natural log, base 10 is the common log, which we just write as log. So this way, by bringing in either one of these two logs, we don't have to use the change of base formula when in our solutions. We can just use our calculator. Alright, and then anyway, we'll go through this process to show that it works. Now, these are the two equations we're going to give an example to. One, a fairly basic equation, and the other one, one I have to do a little bit of work to. So I'm going to solve this for this x. And remember, anytime we're solving an equation, we're solving it for the variable that's in the equation. So we're solving this thing for this x right here. So I can't divide away this 8 because it's being raised to the 2x power. So we need to bring in logs to be able to do this. Now, you can bring in either log you want to, of log or natural log. I'll do a couple with different examples with different logs, but it doesn't matter which one you use. Right? So I'm going to bring in the log of base 10 log on both sides, just the common log, and show you how to do this. Oops. Alright, now again, the idea, the fundamental idea here is if two things are equal, and these two things are equal according to this, then if we plug them into a logarithm and it's the same base logarithm, then that has to be equal. Right? You're plugging in, virtually what this is saying is this is the same thing as this, so when I put it into the log, I'm going to get the same thing out because they were the same thing that went in. Alright, now that's we're already down to this step. We're already down to step 2. Rewrite the equation with a base raised to a power on one side. So this means isolate the exponential part. This one's already isolated, so step 1 was already done. But then we did the base 10 log on both sides of the equations, and then use a property to remove the variable from the exponent. The property they're talking about is that power rule, which says that now that I have a logarithm, and this is the input of the logarithm, this can come down in front of the log, and we can create multiplication here. So we get 2x times the log of 8. Right? And what's our goal? Our goal is to solve for this x, to isolate that x. So we're going to divide away the 2, but we're also going to divide away the log of 8. So we're going to divide away the 2 on this side, and we're also going to divide away the log of 8. Alright, so the 2's cancel, the log of 8's cancel over here. Remember, the log of 8's just a number, so it cancels just like the 2 does. And the exact answer is the log of 4096 divided by 2 times the log of 8. Alright, and this is the exact answer, but again, usually they'll ask you for an approximation here, because usually x is going to be some type of a time or years, so we'd want to approximate it. Alright, so I'm going to put in log of 4096, and I'm going to divide that by parentheses because I have multiplication, 2 times the log of 8. Right, and I get 2. So x is equal to 2. Alright, if we go back and check it, that would mean 8 raised to the 2 times 2 power should equal 4096, and we'll see that it does. Alright, now this one, we want to isolate the exponential part. So this is the part that has the x in the exponent. So we want to isolate it. So the first thing we're going to do here is divide away the 6. Alright, so I've got 4 to the 3x minus 2 power equals 20. Now again, you cannot divide the 20 by the 4. This is being raised to a power. So exponents trump division. We wouldn't be able to do that division anyway. Alright, so we need to bring in a logarithm. Now last time I brought in a common log. This time I'll bring in the natural log and show you that everything works just the same as it did before. Alright, natural log of 20 over here. Now, what does this allow me to do? It allows that exponent to come down in front. Alright, now the exponent has subtraction in there, so I am going to need to put parentheses around that exponent, because what happens is we allow the power rule allows us to multiply the power times the log of the base. So because of that, I do need parentheses around that. Alright, now again, what's our goal now? Our goal is to isolate that guy. So what do I need to do first? I'm going to divide away this natural log of 4 on both sides. Alright, and now that leaves me with, I'm going to come up here, (3x minus 2) equals the natural log of 20 divided by the natural log of 4. Right, now before you write like the natural log of 5 or something, right, the natural log of 20 divided by the natural log of 4, is that equal to the natural log of 5? No. Okay, so don't do it. Don't be tempted to say that. Right, that's not what the quotient rule says. Right, is it equal to the natural log of 16? No, that's not what the quotient rule says. Okay, you got to understand it's inside a single log. If there's division, then I can break it up into subtraction. It's not if two logs are being divided, I can subtract and get the new number. So make sure you understand that you cannot do anything with this. You're just going to hold on to it the way it is. Alright, and now to isolate that x, I add 2 to both sides. So I get 3x is equal to the natural log of 20 over the natural log of 4 plus 2. Alright, and then last thing, divide everything by 3. Alright, so x is equal to the natural log of 20 divided by the natural log of 4 plus 2 all divided by 3. And again, we would approximate that usually. Alright, do this in steps. Don't try to put it all into one step. So natural log of 20 divided by the natural log of 4. Enter, add 2, enter, then divide everything by 3. Alright, so we get about 1.37. The two decimal places. Make sure, 1.387 that is. Make sure to round it as many places as they tell you on your My Math Lab homework, because they'll count off if you don't round it correctly, even though you did all this ugly, nasty work correctly. If you round off incorrectly, you're going to have to go back and do it all again. So make sure you round correctly. Alright, log equations. So a log equation, just like if you think about it, how we've been solving exponential equations, we've been bringing logs into it. How are we going to solve log equations? We're going to bring in exponentials. Okay, they're inverses of one another. Okay, just like if I want to solve an equation with a square, usually I have a square root in there, or if I have a square root, a square. When you are solving an equation, you use the inverse of the function that appears in the equation, usually. Okay, so that's what we're going to use here. We're going to use an exponential equation to solve log equations. Alright, now when we have something like this, 4 log base 3 of x equals 8. Alright, we want to solve this by isolating the log and then converting it to exponential. Alright, usually when we convert to exponential, it's easier to see what the solution is. So just like before when we were doing log equations or exponential equations, we isolated the exponential. We're going to isolate the log here. So I'm going to divide both sides by 4, and I get the log base 3 of x equals -2. Okay, now change it to exponential. So we're going to get 3. Remember how to change it to exponential. Here to here, we get 3 to the -2 power is equal to what? Is equal to x. Alright, so this thing's almost done. 3 to the -2 power means 1 over 3 to the +2 power, and then 3 squared is 9, so x equals a ninth. Alright, now this is what's important. You check log equation solutions. Alright, not a good idea to check them. You have to check them. You have to understand that this is a must now. It's not a good idea. You check log equation solutions. Alright, so how am I going to check that? Just go to your calculator. Alright, don't make it harder than it needs to be. Use your calculator to help you. It's a tool to help you through this course. Use it. Alright, so I've got the log base 3 of x. Alright, remember to do a log of a different base, you'd use the change of base formula. So if I want to do log base 3 of this input, which our input is going to be 1/9, I need to do the log of a ninth, 1/9, and then divide by the log of the base. The base is 3. Alright, so the log of the base. Alright, that's this right here is the log base 3 of 1/9. It's just this is how we have to input it on our calculator. Alright, we hit enter, we get -8. Alright, so 1/9 works. If I wanted to graph it, they said verify the solution graphically. If I graph it, meaning I put left side of the equation on y1, right side in y2, I have to use that change of base formula again. So the log base 3 of x, let me just go ahead and write it down here so you'll have it. Log base 3 of x is the same thing as log of x divided by the log of 3. Alright, that's what I'm making use of here, the change of base formula. So for log of x, close parentheses, divided by the log of 3, close parentheses. Alright, and then on the bottom one, -8, left side in y1, right side in y2, graph it. I'm going to hit zoom 6 to make sure I'm in the standard window. Alright, there's where they intersect. We can't see it here because it hugs so close to the y-axis, but we will verify that that does take place at that 1/9. Alright, 5 is intersection. First curve, that's the log. Make sure that you actually see the cursor before you hit enter. Second curve, enter, guess. Alright, it goes through its process. 0.111111111. Now, you don't want 11111. You want a ninth. Alright, that is a ninth. But if you can't see that that's a ninth, press second, quit, go back to your home screen, press X. It stores the last number it had in there, right, which was from the intersection, and then press math into fraction. Alright, and we see that is a ninth. Alright, so you can convert it to a fraction by using that process. Alright, let's solve this log equation. Again, we want to isolate the log part. We want to isolate this. So we're going to get everything else over to the other side. So I'm going to start by subtracting this 6 over. So it's gone. Now we've got 3 times the natural log of x equals 6. Alright, and then I want to get rid of this 3, so I divide it away. Alright, and now I have the natural log of x is equal to 6 divided by 3 is 2. Alright, now you can, this is what it's wanting us to do, change it to exponential form. You can always rewrite natural log of x as the log base e of x if you get stuck here. Because if you need that base to show up so you can do that little loop thing that I've been showing you guys, then rewrite natural log of x as log base e of x. Alright, this is the same as this. So if you need that e to pop up so you can do this, then do it. Alright, e squared equals x. So there's our answer. Alright, we can always check it. We always should check it because it's a log equation. 6 plus 3 times the natural log of parentheses e squared is our input that we're going to replace x with. Close parentheses on both and then hit enter. We should get 12, and we do. Alright, so that means that is a good solution. Alright, but don't forget to check these things. You got to check log equation solutions. Alright, here when we have equations like this, natural log x plus 3 equals natural log x plus 4. First of all, this is separate from this. Okay, these two things, they're different. This one's in a parenthesis, so the plus 4 is part of the input of the natural log. This is plus 3 outside of parentheses, so it's after we've done the natural log. Okay, so we can't just drop the natural logs at this point. So what we want to do here is group LNs together. And then, oops, we're going to use log properties after that. And we're going to get a single log. Alright, ln in this case. Then convert to exponential. Alright, so it says take this and convert it to the equation exponential form. Well, we can't really do that until we have just a single log. Okay, we have to have a single log to be able to convert it to exponential. Alright, so I'm going to take this natural log of x plus 3 equals natural log of parentheses x plus 4 close parentheses, and I'm going to group these two things together. So I'm going to bring this over to this side. Alright, now this is gone, this is gone. Alright, I have 3 is equal to the natural log of x plus 4 minus the natural log of x. Alright, now I have two logs, same exact base, because they're both natural logs, being subtracted. So this means I can use the quotient rule. Alright, remember the quotient rule says if I have the log base a of x minus the log base a of y, that's the same thing as the log base a of x over y. Okay, and that's what we have here. It's just the natural log. Alright, this thing, same thing works with this is base e, so this is going to work with natural log. So I have subtraction. I can combine them to a single logarithm and put the whatever comes before the minus sign up top, whatever comes after the minus sign, put it down below. So this is going to be x plus 4 over x. Alright, that's what 3 is equal to. So these combine to this, and now we're going to work with this equation. Okay. Now, if you need to, remember this is the log base e of x plus 4 to the x. Alright, so don't forget that, because we're going to transform it into an exponential by taking this base, going across the equal sign to get our exponent, and then coming back, setting it equal to the input. So equation we're going to start off with on the next page is e cubed equals x plus 4 over x. So e cubed equals x plus 4 over x. Alright, what am I going to need to do? I'm going to multiply both sides by x to clear that x out of the denominator. Remember, we want 1x equals, so we're going to have to get rid of the x in the denominator. Alright, so I've got x e cubed equals x plus 4. Now, even though it doesn't look like it right now, this is just a linear equation. Right? And how would I solve an equation if it was 5x equals x plus 4? What would I do? I'd group the x's together on one side and leave the constants on the other. That's exactly what I'm going to do here. I'm going to group these x's together on one side, the constants on the other, and so I've got x e cubed minus x equals 4. Now, after you've done this, this is when it behaves differently than something like this where everything's nice and hunky-dory with whole numbers. We need to factor out this common x. Right? It's common to both. We factor it out. We get e cubed minus 1 equals 4. Alright, and then finally we've got just a single x in the equation. This is always your goal, is to get a single x in the equation and then divide away anything that's being multiplied to it. So e cubed minus 1. E cubed minus 1. Alright, that's gone. And we get our solution as x is equal to 4 over e cubed minus 1. Alright, approximation for that would be 4 divided by parentheses, don't forget your parentheses, e cubed minus 1, enter this number. Okay, now what do I do with that? Well, according to the original equation, this, if I store this answer, store it as x, and then I just rewrite my original equation, the natural log of x plus 3, there's my left side, is that equal to the natural log of, oops, already gave me an parentheses, x plus 4. Alright, hit enter. The decimals match, so that means that this is our solution. Alright, now this technique I use on the calculator, this is a great tool. Let me just run it through it again, what I use. 4 divided by parentheses the entire answer, e to the third power minus 1. Close your parentheses. All that's in the denominator. That's our x. So we're going to hit the store button, store that as x, right, and then we just rewrite our original equation verbatim. Alright, natural log x plus 3. That's the right side of the equation. Natural log of parentheses x plus 4. That's the left side of the equation. Sorry, that's the right side. The other one's left side. Anyway, they're equal. The left side is equal to the right side when x is equal to that number. So that means it is our solution. But make sure you always check.